Open an automotive ECU and you will find a microcontroller, memory, communication interfaces, power electronics, and many other hardware components. But if I ask an AUTOSAR engineer what is inside that ECU from a software architecture point of view, the answer looks completely different. At the highest level, the AUTOSAR Classic platform gives us three major software regions: application software, the Runtime Environment, or RTE, and basic software, or BSW. If you understand what belongs in each region, why the boundaries exist, and how information moves between them, most of the classic AUTOSAR course becomes much easier to understand. So let's build that mental map using an automatic windscreen wiper ECU. Imagine rain begins falling on the windshield. The vehicle has information representing rain intensity. The driver may also select a wiper mode manually. Some software must decide what the wipers should do. That decision belongs conceptually to the vehicle function side of the system. The software should reason about meaningful information such as rain level, driver wiper request, and perhaps vehicle state. It might produce a logical output such as wiper speed request. That is the kind of responsibility we associate with application software. In AUTOSAR Classic, application software is organized using software components. A software component should focus primarily on the function it performs, rather than knowing every low-level detail of the microcontroller underneath it. The wiper control component should not need to contain a register address just because one particular ECU uses one particular timer peripheral. The Classic platform describes application software as mostly hardware independent. Mostly is an important word. The software still executes on real hardware. CPU performance, memory, timing, peripherals, and safety requirements still matter. AUTOSAR is reducing unnecessary hardware dependency, not pretending hardware does not exist. Now look underneath application software. There is a boundary called the runtime environment. The RTE is one of the most important concepts in classic AUTOSAR. From the application's point of view, the RTE represents the interface through which software components communicate with one another and access appropriate basic software functionality. Suppose our wiper control software component needs rain level from another component. The consuming component should not need to know whether that information was calculated locally, received through another ECU, or originated from a different hardware implementation. It interacts through its defined AUTOSAR software interface. The RTE helps realize that communication in the configured ECU. This is why the RTE is sometimes described as middleware, but be careful with that word. The RTE is not the operating system. It is not the CAN bus. It is not another physical ECU network. It is the application-facing software abstraction between application software and the underlying AUTOSAR infrastructure. Now move below the RTE. This is basic software. Basic software contains much of the standardized infrastructure required to make an automotive ECU operate. Instead of every application implementing communication drivers, memory access, diagnostic infrastructure, operating system functionality, hardware access, and ECU management mechanisms independently, these responsibilities are organized below the application. At a high level, AUTOSAR divides basic software into services, ECU abstraction, and microcontroller abstraction, together with complex drivers for specialized cases. We will spend many later lessons examining these areas. For now, think about their direction. Services are relatively far from the physical hardware. They provide infrastructure such as system, memory, communication, and other platform services. ECU abstraction sits closer to the hardware and helps hide details of the particular ECU hardware arrangement. At the hardware-facing end of basic software is the microcontroller abstraction layer, or MCAL. MCAL contains standardized driver concepts for microcontroller peripherals, drivers for things like digital input and output, analog to digital conversion, pulse width modulation, timers, communication controllers, and other microcontroller resources belong in this hardware-facing area. There is one architecture rule I want you to remember visually. MCAL is not a layer underneath basic software. MCAL is part of basic software. Under basic software is the actual microcontroller and ECU hardware. So the mental map is application software at the top, RTE underneath it, basic software underneath the RTE, MCAL inside the hardware-facing bottom of basic software, and the microcontroller hardware underneath the software architecture. Now, follow our wiper request through that map. Rain arrives through the appropriate vehicle or sensor path. At the application level, the wiper control software component reasons about meaningful information. It produces wiper speed request. That request crosses the RTE boundary into the configured infrastructure. The appropriate lower software eventually converts the logical request into hardware-oriented operations. At the hardware-facing end, the microcontroller controls an electrical output. And remember our physical rule, the microcontroller does not directly provide the power required by a wiper motor. The low-power control signal ultimately operates appropriate driver or power electronics, which then control the physical motor. That single example already separates functional logic from software infrastructure and electrical power hardware. There is another AUTOSAR Classic platform concept that explains why this separation works so well. The Virtual Functional Bus, or VFB. The VFB is not a real physical bus, it's an architectural abstraction. At the functional design level, software components can be described in terms of their ports and communication relationships without first embedding every low-level ECU and network detail into the application. Software components can later be mapped to ECUs. If two communicating components end up on the same ECU, their communication is realized within that ECU. If they are allocated to different ECUs, network communication becomes part of the realization. From the application's conceptual viewpoint, the functional interaction remains much more stable. This supports the hardware independence and software reuse we discussed in Lesson 16. So think of the VFB as the abstract communication view, while the configured RTE and lower infrastructure help realize the communication in an actual system. Now, let's correct 4 common beginner mistakes. First, basic software does not mean drivers only. Drivers are only part of the infrastructure. Second, the RTE is not the operating system. The AUTOSAR operating system belongs within basic software. Third, MCAL is not below BSW. It is inside BSW at the hardware-facing end. Fourth, Classic AUTOSAR does not mean one fixed software binary or one identical ECU architecture for every vehicle. The platform is modular and configurable. Different ECUs can use different sets of modules, configurations, hardware, and application software components while following the same overall architectural concepts. Classic also includes complex drivers for specialized situations that do not fit neatly into the normal standardized abstraction path. That capability should not be interpreted as permission to bypass the architecture whenever convenient. Now step back. Why is this architecture so important? Because every layer has a different responsibility. Application software asks, what should the vehicle function do? The RTE asks, how does the application interact through its configured software interfaces? Basic software asks, which common ECU services and hardware-oriented infrastructure are needed to make that functionality execute on this ECU? And the hardware provides the physical computing and electrical resources. This separation is what allows application developers, basic software developers, hardware suppliers, tool vendors, and integrators to work through more clearly defined technical boundaries. For an interview, if you're asked to explain AUTOSAR Classic platform architecture, start with the 3 major software layers. Application software contains vehicle function software components and is mostly hardware independent. The RTE provides the application-facing interface for communication between software components and access toward basic software. Basic software provides standardized services, ECU abstraction, microcontroller abstraction, and other infrastructure required by the ECU. Underneath that software runs the actual microcontroller hardware. Then mention the virtual functional bus as the abstraction that helps decouple functional communication from the detailed infrastructure. That answer shows architecture understanding rather than acronym memorization. Subscribe if you want to keep turning this architecture map into the actual modules, signal paths, and engineering decisions used in AUTOSAR projects. We now understand the basic shape of the Classic platform, but AUTOSAR also defines another platform for a very different computing environment. In Lesson 18, we'll introduce the AUTOSAR Adaptive Platform and see why a high-performance automotive computer needs a different software architecture from a deeply embedded Classic ECU.